Welcome everyone. We'll start the class after a few minutes so that others could join. Okay, so let's start the session. So as you all know, I am Dibyendu. This is problem solving sessions for thermal physics course instructed by Professor Debamalya Banerjee of IIT Kanpur, and this is the assignment session for week number 10. And uh, let's start. Let's start the session. Okay, so the first problem says so that the difference in specific heat Cp minus Cv is related to isothermal compressibility Kt. Sorry, Kt by which of the following relations, where alpha is the volume expansion coefficient. So in today's class, uh, all of the problems are mainly focused on using different Maxwell relations and different differential, different how we can manipulate different differentials and different functional of different thermodynamic variables. So that will be based on those things. So first thing first, so let me go back to this. So we have to need to find the difference. We need to find Cp minus Cv. Now what is Cp? Cp is T del S del T at constant P, right? What is Cv? Cv is T del S del T at constant V. Now we need to find their difference. Okay. Now, since entropy, we cannot uh, get some information from entropy, we need to find the CP/CV compact relation. Now, S is a function of T and V. Now, if we can write the differential of that, del ds should be delta S delta T keeping V fixed dt plus delta S delta V keeping T fixed dV, right? So del S del T at constant P, then we are differentiating this term with respect to T keeping P fixed. This term will be as usual with their del S del T V del T del T. If we differentiate dt with respect to dt at constant P, it will be 1 plus del S del V T and del V del T at constant P, right? Now, so since there is only T multiplied, we will first get del S del T with keeping P fixed minus del S del T V. That will be del S del V T del V del T P, right? Now, if we multiply T, then this will be T del S del T P minus T del S del T V is equal to T del S del V T times T del V del T P. Now, del S del V del T will not give you any physical relation, so we have to play with that. So first thing first, so del P del T, hello. So we need to first use the Maxwell relation. So I will give you some mnemonics based on this. So let's say this is S S P T V. So SVT means SVT, which can be written as like this, SVT, that will be equals to like this. So this is like this, this is like this. Since they are in the same direction, means downward direction, so that will be positive. So this will be, so del S del V T will be del P del T V. Let me join. Now this thing we can replace. So del P del T V can be written there. So T del P del T V del V del T P. So let me write, add one page here. Okay, now we have to write the expression for compressibility KT and alpha, right? So what is KT? KT is written in terms of, so KT is, so isothermal compressibility kappa T is minus 1 by V del V del P T, and expands, and what is volume expansion coefficient? So volume expansion coefficient alpha is 1 by V del V del T, keeping P fixed, right? Now that is done. Now we have to arrange, but so here all the differential is V with respect to Vp and Vt, but here there is Vt, but there is Pt also there. Now we have to write this PTV in terms of Vp. Okay, so for that we'll write in terms of, we'll use the Jacobian form. Okay, so for that let me write, sorry, let me write, let me see that recording is on. Yes, so we need to write this expression del P del T V. So let's see, del P del T V can be written, so the notation to write is PV del of TV. So the differential in the numerator P and with the fixed variable, so del PV, and denominator T and V. So this is like this. So that to write this, from this we have to first the differential form in the numerator here, and the fixed term here, and the term in the denominator here, and the fixed term here. Now del P V del T V. Now we have to find the Vp thing, because here Vt has been given. So for that Vp thing, so let's say there is PV is there. Okay, PT Vt, yes. So we can write PT VTP del P del T del V del T. Yeah. Now here we can write in terms of del PVT as del PT. Yes, sorry, del PV divided by del PT. So this term was not there, so I have to write again so that it cancels out, del PT del. Now we have to write this term del T V. So please carefully see all the steps, because this is the first problem using all these Maxwell relations. So you should have followed all the lectures. Anyway, when you will see these steps, you will get the feelings of or flavor of it, right? Now here P is in these two sides, so we'll just revert it like this, del VT del VT del PT. Since we have changed the order in numerator and denominator both, in two places we have changed the order, so there will be no minus sign. But here we have changed del PT divided by del VT. So we have changed only 1, so there will be 1 minus sign. And after writing this will be minus del Vt divided by del Pt times del. So let me write it in terms of, so this T is fixed, so there will be T constant, there is T also fixed, this will be T constant. Let me add one more people. Yeah. Now here, so T is fixed, so that's why T here, T is fixed, common here, so T is fixed. This will be del V del P, and this will be del P del V, right? Okay, so now we will add these two things there again. Did I do some mistakes? Del P del V T, del V del T P, del V del T P. No, there is mistake, one mistake. So this is PV, right? Del PV, del PV. So this will be V and P, and this will be T and P. So this will be del V del T with P fixed. So let me write again. So this will be minus del V del T P. This will be del P del V T. Now I will plug this thing, this expression, into this expression. So then Cp minus Cv becomes, so there was one T again, so T, and del P del Tv, let me write it here so that there will not be no more confusion, and del V del T P, del V del T P. So for this expression I will substitute this, so this will be minus T del P del V T times del V del T P whole square, because there is one del V del T P here and also one here, and after substituting this expression there is also one del V del T P here, so that will be square. Now I will arrange it in such a way that it will give in terms of this thing. So let's say equals to minus T del P del V, there is only one, so let me write del P del V del P del V T times V. So I have, okay, now here there is del V del T square, so del V del T is 1 by V, so 1 by V del V del T at P whole square. So I have added 1 by V here because there is one V, there is one V square, 1 by V square, so that will be 1 by V, so I have to product with 1 V. Now this thing, this is 1 by KT, so this will be minus T by kappa T, and this is alpha square, so this is alpha square, and this is V, so this is V. So now it comes to be, okay, so the one minus will be absorbed here, so the minus thing will be gone, so this will be T alpha square V divided by kappa T. Okay, so this is the correct option, T alpha square V by kappa T. So this option is the correct option. So here we have used different differential multivariable calculus and also Maxwell relation. Okay, now I will go through this thing because this is the first problem I want to I want you guys to be familiar with this convention. So I will again talk about this thing. Okay. So in this problem, we are asked to find what is the expression will be for Cp minus Cv. Now we know that for Cp, pin myself. So for Cp, Cp is T times del S del T at constant P. And what is Cv? Cv is T times del S del T at constant V. So we have written this thing. Now S, which is entropy, entropy is function of any kind of function can be written of other two thermodynamic variables. So entropy is a thermodynamic variables that can be written in terms of other two thermodynamic variables. So entropy can be written in terms of Tv or Tp. So here you have written Tv. So ds, which is the differential form of S, ds can be written in terms of, so this is the multivariable calculus, which is the change in S with respect to T, that is del S del T, keeping one variable, another variable fixed, which is V. So del S del T at constant V times dt, plus similarly it will be applicable for other variable also. That's why del S del V at constant T times dV. So ds can be written in terms of del S del T V dt plus del S del V del S del V T dV. Okay. Now that is done. Now we have differentiate that equation with respect to T, keeping P fixed. That's why we can write del S del T at constant P is equal to del S del T at constant V plus del S del V at constant T times del S so we are differentiating with respect to T, that will be del V del T with constant P. Now we get the expression for del S del T at constant P. Now what will happen when del S del T at constant P if we differentiate with respect to del S del if we take the difference between del S del T del constant P minus del S del T constant V, that will become del S del V del S V T times del V del T constant P. Okay. So okay, so this is done. Now we have multiply with respect to we have multiplied a T in this expression. So this will become T del S del T P minus T del S del T V, that will be T del S del V T del V del T P. Now del S del V T can be written in terms of del P del T V. How can we write? That is the Maxwell relation. For the Maxwell relation, there is a mnemonic diagram. We have to write SPTV. To remember it easily, you can use the mnemonic as special program on TV, and you have to write in terms of clockwise direction. Now, how to use the Maxwell relations? First start from the denominator, then the from numerator, then denominator, then the constant term. So del S del V T, that means numerator is S, denominator is V, and T is fixed. So the arrow is like this. That could be written, you have to just take the other side, that is P. So P T V, this is the same thing. So del P del T P. Now since from here to here the this arrow are in the same direction, that is downward, there will be no minus sign. Now if it so happens that this direction will be in other side, means one is upwards and one is downward, then there will be one minus sign. That is the way to read it. That's why del S del V at constant T can be written in terms of del P del T at constant V. Now, so this is Cp, this is Cv. So Cp minus Cv becomes T del P del T at constant V times del V del T at constant P. Remember this expression, this will be also useful in the next time. Now if we write this, we don't have any measurable quantity like isothermal compressibility and alpha in terms of P by T. For that we have to uh, do some manipulation. Now isothermal compressibility is minus 1 by V del P at constant T, and volume expansion coefficient alpha is 1 by V del T at constant T. So del P del T V here we have written in terms of Jacobian, that can be written in terms of, so when there is numerator will be P and constant term will be accompanied by the comma sign. So PV, that's why PV and TV. Now we have inserted one PT here. So since we have inserted one PT, there will be one PT here also. Now this is del P, this is PV PT, PT TV. Now for that we have just reversed once. We will keep all the constant thing in the right hand side. Constant mean when in the numerator and denominator in both cases there will be fixed variable, same variable, which is P here. Then we have just reverse the order, that will be delta Vp delta Tp, and here this is delta Pt delta Vt. So here we can write it in terms of del V del T at constant P, and here it is del P del V at constant T. Here we have changed Tv, only one term we have changed, so that's why one minus sign here. So that's why we can write del B del Tp del P del Vt. Now we have substituted del P del Tv of this expression. So after substitution, this is the term. Now we have arranged it in terms of Kt and alpha. That's why for del P del Vt we have written 1 V. So V del P del Vt it's 1 by Kt, because minus of V del P del Vt is 1 by Kt, because if you take the 1 by Kt, that will be minus V del P del Vt. Okay, so that is kappa T is gone there. Now we have inserted one extra V. For this thing del V del T square, we have written 1 by V del T square. So there is 1 V square and 1 V. So 1 by V square and 1 V, that will give you 1 V, but there is no V in this expression. That's why we have to write 1 V also to to get the expression without any V. So that gives you T is there T, and for their minus V W del P del T is 1 by Kt. So that's why 1 by Kt, and it is alpha square and V. So that's why we can write it in terms of T alpha square V divided by kappa T. Okay. So this is a longer calculations, and please if you follow the lectures and if you follow this calculation, that will be useful. So please follow the expression. Okay. So now let me go to the next problem. Okay. Okay. So this question says, for a homogeneous ideal gas, find out the ratio of adiabatic elasticity ES, which is defined as minus V del P at constant S. Hello. Yes, Renuka, tell me if you have any queries. Okay. So adiabatic elasticity ES is minus V del V at constant S. So adiabatic means S is constant, that's why constant S is there. Isothermal elasticity ET is minus V del V at constant T. Okay. These two terms are written. Now we have to find it. Okay. So let me do this problem for you. So here So the ratio ES by ET will be del P del V S divided by del P del V T. Now del P del V S can be written in terms of, how can we write it? So I will keep it here. So let's fix this expression. So this is the multivariable equation. So please follow the steps. That is very much important. If you don't follow it, then you cannot do this, because there are some integrate. So how can I write this thing? So first we will write del. So del in both sides. Now numerator thing goes here, numerator thing goes here, denominator thing goes here, denominator thing goes here. There will be one comma. The constant thing will be followed. Okay, constant thing is followed. Okay, now I have so to write in terms of CP, I will write so tactfully. So there is PS. Now CP is del S del T at constant P, right? So CP is del S del T at constant P. So I have got one S here. So ideally I have to find a T. So look, I have so since this is in the S in the second second place, so I have written T here. There will be one comma, and for constant P, because CP there is constant P, so I have written one P here. Okay. Now for, since there is no PT, so I have to write here it PT. Then del Vs. Okay. So that is the thing. Now for this is, so I have to change the order. So first here to here and here to here. So this will be SP, and I have changed also this TP. So P is in the second column and it is fixed quantity. So delta PT delta Vs. So it becomes del S del T at fixed P and delta PT delta Vs. Now similarly we will do this for this thing, del P del V T. For this again, del P T divided by del V T. So this is a way to solve it. Now for this we need, there is one P and one V. So we have to write del PT PT. So CP is there, so we need to have with respect to S. So this will be ST. So this will be ST in terms of delta V T. Okay. So PTST PT okay. So we can write in terms of SV. Okay, SV. So this is SV. Now this will SVVT. So there is one PTVS. So I will change the ordering of these two things. Okay. So first one minus sign, this will be PT delta Vs, because I have changed the order of this and this, times once again one minus, because del is V and delta TV. 1 minus because I have changed the ordering, that becomes delta S delta T V times dPT dVs. Now these thing are similar. Let me box it. This thing and this thing are same. So this will cancel out when we will take the ratio, right? Let me add one page. So we have written in terms of this. That's why when you take ES by ET, that becomes ES by ET, that is del P by del V S del P by del V T, that becomes del S by del T P times T PTVS PTVS. Similarly here del S del T V D PT VS. So this will cancels out and it boils down to del S del T P divided by del S del T V, and we will multiply T both sides. So del S del T P times T del S del T V. So this is Cp, this is Cv. What is Cp value? 50, and this is 42. So this will be 50 by 42. Okay. So what is the value coming out to be? For my case, it is coming out to be 1.19. So option A is the correct answer for me. Okay, so please follow the steps here. I will again come back when after the after all the problems will be solved, because if you don't follow it properly, then there will be some problem. Okay, so you have to follow it properly. So the differential and all these things, you need to follow it. Okay, so this question says, for a thermodynamic system, the expression T del S del T P minus T del S del T V is always equal to what? So please tell me what is the option, which option will be correct. I have just solved it few minutes back. Okay, no response, then I have to solve it. Same thing. Now S is a function of TV. So ds can be written in terms of del S del T at constant V dt plus del S del V at constant T dV. Okay, so del S del T P will be what that will be? Will be del S del T P plus del S del V T dV dt P. So del S del T P minus del S del dV is del S del V T times del V del T P. Now using same Maxwell relation, so SVT will be PTV. So del S del V T will be del P. So that becomes del P del T V dV dt P. So T del S del T P minus T del S del T V will be T del P del T V del V del T P. So option D is the correct answer, right? So what I have just did in the same way, we have just solved it. Okay. So any question? So I have used here Maxwell relation. Okay, so if the equation of state is given by V is equal to RT by P minus B by T cube, where B is a constant, which of the following is true? First, we have to find out what is the expression for del Cp by del Pt in terms of that. Okay, because equation of is given, what kind of differential we need to know that we can get after getting the expression for del Cp del P at constant T. Okay, so let me write here. So Cp is T del S del T P. So del Cp del P at constant T will be del P del P times T del S del T P. Okay, now first expression give me, so now you can see here we can change, since here t is fixed, so we can take t out of the term. So this will become t uh, del p del s del t p t. There we can write t del t times del s del p t times p. How can we write it? Let's say a function u, which is u is a function of x and y. So del 2 u del x del y is del x del u del y, keeping x fixed and here keeping y fixed. Similarly, del y keeping x fixed and here keeping y fixed. Okay, so we have used the multivariable calculus. So this thing we have written. Now we will use the Maxwell relation. So SP TV. So SPT means this way and this will be this way. So this is in this direction, this is in this direction. So there will be some negative. So delta S delta P at constant T will be delta V delta T at constant P minus sign. Now we will substitute this term into this equation. Okay, let me add one page. Okay, so we will add that into these equations. So del S del P T will be del P del T P. Okay, so now it becomes CP becomes yeah. So now CP becomes minus T del T del T S del T, keeping P fixed, and we will change it. Del S del Pt is equal to minus del V del Tp. So del V del T P, right? So minus sign. So this becomes then like this. Now this can be written in terms of minus T del 2V del T2, keeping P fixed. Now this expression we got. Now let's see what is the equation of state. RT by P minus B by TQ. Okay. So the equation of state. So let me write the equation of state. So the equation of state is V is equal to RT by small p minus B by T cube. So what is then del V del T at constant P. Okay, so this will be del Cp del P at constant T. This is del Cp del P at constant T. What is del V del Tp? That will be, I have to differentiate this expression keeping P fixed with respect to T. So if we differentiate this expression keeping P fixed with respect to T, this will be R by P. So this will be R by P. And for this thing, this will be minus 3B T to the power 4. There is one minus sign again. This will be plus. What will be again? Del V del T to P will be del T times del V del T at constant P time P fixed. So here we have to differentiate with respect to this with respect to T keeping P fixed. So here there is no T, so that will be 0, first term will be 0, plus here this will be minus 12B T to the power 5. Okay. Now I have to substitute into this thing. So del Cp del P at T will be minus T times minus 12B T to the power 5. That will give me 12B T to the power 4. Okay. So the equation, the answer it, the question it asks is the which of the following relations is true. So this is the true relation. Del P at constant T varies as T to the power minus 4. Right? Is it clear? Should I move to the next or okay, let me go through this once more because it is quite difficult for fast go you to understand. So let me take this laser pointer. So Cp is d times del S del T at constant P. Now we have to get this expression del Cp del P at constant T. That means how Cp changes with respect to P keeping T fixed. Then we have to differentiate this expression with respect to P keeping T fixed. That's why we have written del P at constant T of T del S del T at P. Now here we have used the multivariable calculus. What does multivariable calculus say? That is if a function u is a function of x and y, then delta u del x del y can be written in terms of del x keeping y fixed, del u del y keeping x fixed, and then that is also equals to, we have changed the order here, del y keeping x fixed of del u del x keeping y fixed. That we have used here. We have taken out del T at constant P outside, del T constant P outside, and we have inserted del P at constant T inside. Now del S del P at constant T, that can be written in terms of del S del P constant T will be minus del V del T at constant P because of the Maxwell relation. I have told you guys that how to find the Maxwell relation. You have to write SPTV in this manner, and you have to start from the variable which is in numerator and passing through the variable in the denominator, and you have to stop at where the constant term, that is a fixed term, is there, that is T. That's why we started with S, which is in the numerator, and then again passing through the denominator and stops at T, which is a constant variable. That will be equals to, we have to change one thing, del V del T So just one thing, where it has started, we have to go below one step. That will give you this direction. Why not this direction? This is not this directions because we have to end where it has so this is like the p is, it is in the variable, there it will be constant. Okay, so p is in constant, t is variable, so vtp. So vtp. Why minus sign? Minus sign because starting from the numerator to the constant value, if their arrows are in the different two directions, means it is in upward direction, it is in downward direction, there will be one minus sign. So you have to take care of all of these situations. Okay, that's why del s del p at constant t is minus del s del v del t at constant p. Okay, so let me write using here. So now we have substituted this term del v del t p. So here I have to write it using Maxwell relation. Let me write it using. So now we have substituted that del s del p at constant t like this. Now it is just like del 2 v del t 2 p, and after, so we got the equation of stored that was given. Now we have to find del v del t at constant p. So here this term has t, so this will be r by p, and this will be my 3b t to the power 4. Again we have to differentiate with respect to t again of this quantity. So after that it will become minus 12b by t to the power 5. So that's how we have written del cp del p at constant t is minus t times this expression del 2v del t to p. So minus 12b to the power 5, that becomes 12b to the power 4. Okay, so this is the total calculations that we need to keep in mind, because we have to play around all these multivariable calculus and using Maxwell relations and using different TDS equations. Okay, so please keep in mind all these things, and in exam I can guarantee you there will be one or two questions, some questions from this section, because these are very methodical and laborious, so we have to take care of these things. Okay, so let me go to the next problem. So next problem says, if the volume expansivity is given as alpha, which is 1 by v del v del t, where here you have to fixed p, then find the ratio of adiabatic to isobaric volume expansivity. Okay, so adiabatic volume expansivity, that is alpha s, that is 1 by v del v del t, keeping s fixed, and isobaric volume expansivity is alpha p, which is 1 by v del v del t at constant p. Now here just see the question, here it is given Cp and Cv. Okay, so I have to write this equation with in terms of Cp and Cv. First clue, how Cp is written? Cp is written T del S del T at constant P, and Cv is written T del S del T at constant V. So I have to write in terms of this thing. Okay, let's play around those expressions. Okay, so alpha s, so alpha s by alpha p will be 1 by v del t at constant s divided by 1 by v del t at constant p. That will give you del v del t at constant s divided by del v del t at constant. Okay, so this is a term that we can write in terms of del s del t at constant v divided by uh, divided by minus t minus. So we will see how can you write it. Okay, so this is for del v del t p. This is written in terms of Cp minus Cv with respect to that term. So let me write it here. Del v del t. First, I have to take care of if there is any Sp Tv. VTS, or we can write it TVS, and VTP will be SVT. Okay, so what is TVS? TVS will be like this. So del S, sorry, del T, not TVS. This will be TSV. So VTS. So del T del V at constant S. This is in upward sign. This is in bottom. So there will be minus del P del T constant V. So del P del T constant V is been given. Okay, so let me write in terms of this. So here del P del T constant V is del of PV del of TV. Now I have to write in terms of, so delta S V divided by delta T V. Okay, now we have written one delta S here, so this will be delta PV in terms of delta S V. Okay, so this becomes del S del T V del P del S V, right? Now we'll get del V del T. Okay, sorry, I have to add one page. So here this is del V del T at constant V. So del V del T at constant P. Now del V del T at constant P, that can be written del V del T at constant P. Now look at this PSV. So Del V del TP is there. Let's not worry about this thing. Okay. So here we got one expression PSV, this expression. So let me write here. So del P del S at constant V. Again SPTV. So PSV, that means PSV. Now we can write like this. We can write in terms of like this. So this is upward, this is downward. So we can write del P del S V in terms of, how can you write that? Del T del V at constant S, right? Del T del P del S del P at constant V, del S del P at constant T, that will be del V del T at constant P. Del S, so here del P del S del P del S. Okay, let's not worry about that. Let's write in terms of like this, S P T V. So del P del S V is 1 by del S del P V, right? So PSV will be TVS, VTS. VTS is PT CV minus CP is del P del T. Okay, so here that is del V del T P, del V del T P, and there is one from this thing. We are getting one del S del T V and one, let me check it, PV TV, PV TV, SV SV, SV SV. That will give you del S del TV. This will give you del P del S V, and del P del S V will be same as, del P del S V will be same as del T del V S, del T del V S. It will be del P del V S, del V del T S. Okay. VSTS VT ST. So here this is coming out to be del V del T P. Now if we write del P del S, so del S del P P, and so again alpha S by alpha P will be del S del T V times del P del S V. right? Del P del S V, right? Mm, VT P VTS VTS VT del S del T V. There should be one minus. There should be one minus. This will be minus. So yes. Okay. Now, so remember, hold on to this point. So there will be one minus del V del T del V del T P. Okay. Now you know TdS is equal to du plus Pd. Okay. So here we can write is equal to del S del T V divided by minus T del V del T P times del S del P V del S del P V. Okay. Now if you remember, del S del P V is equals to, yes, del S del P V del S del P V is equals to del P del T V. Okay. Now if that is true, then we can write del S del T V equals to minus T del V del T P times del P del T V. Hmm. T del P del T T. Yeah. So this is then, sorry, no, not T. So if we, this is also T, this is T, this is CV, right? Now again I have to add one page more. Now again, so alpha S by alpha P will be T del S del TV, that is CV, divided by minus T del P del T V dV dt P. Okay, that's true, right? So now del P del T V, how can we write this? Del P, now we know from previous expression here that T del P del T V del V del T P is Cp minus Cv, but there is minus sign, so this will be Cv minus Cp. Okay, so minus, we know T dP dt V times dV dt P is Cp minus Cv. So this will be Cv by Cv minus Cp. Now what is Cv? 4250. So this will be, so alpha S by alpha P will be 42 divided by minus 8. That will be 5.25 minus, I'll write it here, Cp is 50, Cv is 42. So option B is the correct answer. Okay, so lots of calculations, so please follow all these calculations. Okay, so the next problem says, for a system the equation of state is given by P is equal to f of v, which is a function of v times t, and we need to find del s del v at constant t. Okay, so let me write here. Okay, so we have to find, so equation of state P is equal to f of v times t. We need to find del s del v at constant t. Again, write down this expression SVTV. So del s del Vt, that means this thing. So we have to find del P del T at constant V. Both are in the same direction. So del s del Vt will be del P del T V. So this is using Maxwell relation. So using Maxwell relation. Now P is given in terms of this. Then what is del P del T V? Del P del T V then again will be f by v. So del s del v t will be f of v. Now what is f of v? F of v is p by t. So this is p by t. So option E is the correct option. Okay. So using Maxwell relation is sometimes handy. Most of the times using Maxwell relation is very handy because it actually use all these simplified equations. So that is one advantage over other differentials. Now here the question says if G and F are Gibbs free energy and Helmholtz free energy respectively, then which of the following is true? F is equal to delta of GV del VT, and there are multiple options. Let's just first find out how to find it. Okay, so first of all, Gibbs free energy, G will be written in terms of Gibbs free energy. Gibbs free energy, and this is F, which is Helmholtz free energy. G is F plus PV. Then I can write F is G minus PV. Now I am going to let you know a certain mnemonic diagram. So this is like this. So this is so always remember this like this. So good physicists have studied under very fine teachers. So these are the different, potential, like Gibbs potential, Helmholtz free energy, different free energies, okay, F and T. Now to read it, if I have to find one differential, let's say dg, then this dg will be written in terms of dp and dt with its canonical conjugate. What is canonical conjugate? So let me write in terms of that. First, we will follow this method, this normal Cartesian method, that in this direction positive. So if it is upside positive, and our right hand side is positive, means, let me give you one example. Let's say dg. So we have to find the differential of dg. So what is the neighborhood variable, which is p. Now how to go from g to p? Like this. So this is in right hand direction. So this will be dp, and other variable which is closer to this is t. So there will be dt. Now since this is in the right hand direction, there will be positive, and it is in downward, this will be negative. What is the canonical conjugate variable of p? This is v. What is canonical conjugate variable of t? This is s. So that's the way you can write it. So to write, let me write, to write any free energy in differential form, we can write using the closest variable in the diagram. Okay, so using in this diagram, we can write this thing. Okay, so if that's the case, then what will be p? So what will be v? V is del g del p at constant t. So from here we can write. Let me add one more page. So dg is v dp minus s dt. So v is del g del p at constant t, because if t is constant, this term is 0. So v will be del g del p at constant t. Now we will write in terms of this. So f is g minus p del g del p t. Now we can write this thing p. If we have to absorb it, how can you write it? How can you write using this thing? So let's write it in terms of del d of. So if we write ddp of g by p, that becomes 1 is 1 by p del g del p, with keeping t fixed. Another thing is minus 1 by p square g. del Gp del T. Now see, there is one minus sign. So if we multiply a P square here, this will be P del Gp del T, and this will be minus G, so which is like this, but there is a one minus sign, so I will write minus P square del P G by P and keeping T fixed, right? So this is a term. So if that is the case, then we can write F is minus P square del P G by P T. Now this is, if P square in this direction, so we can write uh, minus 1 by P square dP, this total this thing. So let me write it in terms of this. So del of G by P divided by minus is here, minus 1 by P square dP, and whole thing is in T. You can write it because there is no T. Now what is this thing? If we write d of 1 by P, what is this? D of 1 by P, delta of 1 by P is minus 1 by P square del P, that is precisely this here. So you can write d of G by P times delta 1 by P, keeping it on T constant. So this is the correct option, this one. D of G by P divided by delta of 1 by P T. Okay, so let me go to the next problem. This problem says del H del P at constant S. So again we have learned how to read this mnemonic diagram. So I will draw this diagram. This is G P. Good physicists have studied under very fine teachers. So delta dH, it can be written in terms of ds. This is in right hand direction, so this will be positive. This is in upward direction, these two will be positive, plus then plus dp. What is canonical variable of S? This is T. Canonical variable of P, this is V. So if that is the case, then del H del P keeping S fixed will give you V. So V is the correct answer. So let me write here. So we have to multiply the differential of thermodynamic variable with its canonical conjugate variable. Okay, that is the case. Now this one, sir. For any known material, the value of del P del Vt, what is that value? Now del P del Vt, what does it mean? Del P del Vt, what does it mean? This tells how pressure changes with volume change, keeping T fixed. Positive, when it will be positive? When P proportional to V. Negative, when P is like this, right? Now, most of the cases, as P increases, V decreases. If you take one chamber of ideal gas and if you put pressure, volume decreases, right? That's why most of the cases for any known material, the value of del P del Pt is negative. Okay, so that's that. Now this is the last equation, is calculate the change in, question says calculate the change in Gibbs free energy of the following reaction, which is C6H6 in the liquid form plus 15 by 2 O2G plus 6 CO2 plus 3 H2OG. Given the formation energies for C6H6, CO2, H2O2 is given by that. So for oxygen it is 0. So since it is not given, so we will find it 0. So let's write it. So formation energy is 0 for O2. Okay. Now how can we solve it? Change in Gibbs free energy, that is delta G, will be Gibbs free energy of product minus Gibbs free energy of reactant, which can be written again, delta G is summation over G of product minus G of reactant. So formation energy is given. So for here there is, so 172.8. So for CO2 there is 6 mole. So 6 times 228.6. So there is, for CO2 it is minus 394. So there will be minus 394.4. 3H2O2, that will be 3H2O is minus 228.6, and then again minus for C6H6, that will be 172.8, and plus 15 by 2 moles of oxygen, that is 0. And if you do the calculations, then del G becomes minus 3225 kilojoule per mole. So that's the thing. So option A is correct. Okay, so that's end. So I will shortly tell you about some Maxwell relation and this mnemonic diagram. So for this mnemonic diagram, what we have to know. So these good physicists have studied under very fine teachers. You have to remember it, and you have to draw like this shape, and you start from G. So G, P, H, S, U, V, F, T. And if you want to write the differential of these free energies, G, H, F, S, or a G, H, U, F. So the differential of G, that is dG, can be written in terms of differential of its neighbor thermodynamic variable. What is G's neighbor thermodynamic variable? Which is P and T. So dG will be dG equals to something times dP plus something times dt, and the sign of dP and dt will depend on how they are where they are with respect to G. Now P is in the right hand direction from G, and G is in the downward direction from G. So for downward direction it will be negative, for upward direction it will be positive, for right hand direction it will be positive, for left hand direction it will be negative. That's why dG is VdP and minus dt. Why V and S? Because these are canonical conjugate variable for P and T respectively. Because what is canonical conjugate variable? Canonical conjugate variable is if two variables, if you product their dimension should match the dimension of energy, ml to the power minus 2 t to ml square t to the power minus 2. So VdP same, SDT same. That's why we have used here also for DH. For H, two closer to very close variables are P and S. Their their closest neighbors P and S, and S is at the right hand side from H, and P is at towards upward from H. That's why DH is equal to TDS plus VdP. Okay, that's why del H del P, we have written del H del P in terms of this. So please follow all these calculations, and then it will be easier for you to do the all these things. Okay, so any questions? So if there is no question, let's end the session here. Okay, we will meet again. There are two more classes, that is on 8th and 15th, and after that I will take one more class, that is will be one summarizing class, that will be probably 16th or 17th. You will get notified, you will be notified. So we will see you, we will meet again on Monday 8th April. Okay, so I'm just ending the recording.